All right, let's get started. So, I have a question. So this is the problem I graded, is that correct? Or haven't graded yet, but this is the problem I am going to grade. So here's my question. So for some of you guys said to apply the rule of a squared plus 2ab plus b squared. I get it. I know exactly where you guys got it from. Was that in the notes anywhere? So my question to you is, where did we get it from? Where did we get it from? Did I mention anything about this part in class? Where's the power attached to? Parentheses. Which means we got to write the parentheses how many times? Twice. Or however many times the exponent says, right? Am I correct by saying that every single time there's a parentheses and a power, I mention those words? Okay. Now, if I didn't, please let me know. Did I mention anything about that we're not going to FOIL, we're going to double distribute? So again, I ask, where did the a squared plus 2ab, or in this case, minus 2ab plus b squared came from? Now, since nobody's answering, maybe nobody in this class actually did that. Let's see. Nope, never mind. First one to pull up. Now let me ask you guys this. If you guys didn't know how to do it, have I ever say no when you ask the question? I explained it, yes? The only thing you need to do is open the lab work early. That's it. I don't mind answering the question. I don't have a problem with it whatsoever. Most of you guys decide not to open the lab work early. So how do you guys want me to grade this? If that's not, if you guys use a squared minus 2ab plus b squared, should I just give you a 10%? And just say that you cheated? Second paper, same thing happened. Third paper, same thing happened. I don't even understand what this means. When exponent next to parentheses, we rewrite the equation of the number exponent. again, please explain to me where we got it from. Are you afraid I'm going to yell at you? Is that what you're afraid of? Have I yelled at all this semester? Number 2, the one that I sent to you guys. But what does it mean to use the a squared formula?
So I learned is basically like since this one is like times 2, so I did it times 2. Then after that, I do like 2 times 2, give you like 4 squared.
No. I don't know what this a squared formula means. What does it mean by a squared formula?
So it's double this. I know I don't know. That's how I did it.
But here's the question. Did I ever mention this first part in class?
But I have it on my notes because I took that class.
No, but did I mention this in class? No? Is this your class? No, this is not your class. Let's go to your class. So that this way I'm not speaking out of terms here. Do you remember these problems here? Why do I have this in red? The first question I ask is, was the exponent attached to the parentheses? That means the parentheses has to be written so many times. That's the reason why we write it twice. It's because the parentheses is being raised to the second power. That's not what you said on there.
Because it's 2 times.
Again, it's not a formula.
But everyone learned different.
Oh, I'm not disagreeing with you by any means. What I'm saying is, so again, I will say this again. If you learned it a different way, ask the question, can I do it this way? Okay? If you say that, and I say yes, or I tell you why no, if I say yes, this one, when I see the lab work, I'm not going to be surprised on where this came from. Does that make sense? Right? Because when you say formula, this is what I think of. Because there is a formula. There is a formula. So when you say formula, this is what I'm thinking of. Does that make sense? Okay. Is this anywhere in the notes? No. So that's why I'm asking. Where did it come from? Now, day 1, I urge you to use AI, use ChatGPT. Is that true? Okay. Let's take a look at what Chat says. I already actually know what Chat's going to say. Let's take a photo. There it is. Awesome. Next. Come on. Next. Next. There we go. Can you help me solve number 2? I know exactly what Chat's going to say because I already did it yesterday. And that's where I saw the formula. Even though I already know the formula. Apparently it's going to be slow. internet must be awesome right now. Am I right by saying that this is exactly what it's saying using the formula? So what should you tell it? If you look in the notes and this nowhere in the notes, what should you say to it? What is the words I use that we should do after writing this out twice? What should we do? Double distribute. True? We've heard those words. Okay. So how about if I went in and say, hey, could you do this problem? With double distributing. Oh, I keep on hitting enter. I got to hit the arrow. Like it's a text message or something. Actually, text message, don't you hit return, it goes return as well. Actually, when I did it last night, it gave me FOIL. And I said, do it without the FOIL. I want double distributing. Are you guys seeing what I'm saying? So again, now, did anybody say anything about adding all the terms, like terms? And what like term means? Right? Remember, what we know is a guide, right? Is a guide for Susie Q. Q keeps on moving desk. Every time someone says, I'm like, Susie Q, right? The guide is for Susie Q. Because when I say to you like terms, majority of you guys won't know what the heck like terms are until I explain what like terms are. Does that make sense? Yeah. Same thing with Susie Q. Susie Q, she's going to see like terms. What do you mean by like terms? I don't understand. So for me, it's about merging what I said in class and what AI is giving you. I said to you guys that you guys got to be self-advocates. That means if something is not right, ask for it. If you don't know how to do a problem, ask in class. I don't mind explaining it. What does the rubric say? Huh? I like your honesty. I'm very glad that I'm honest about it. It makes me chuckle because, and I can't say I worked really hard on the rubric by any means, but because a lot of it had to do with, so if you look at the rubric, and I want you to make sure that when it comes to a paper, well, I'm sorry, I should say this. Anything with a rubric, you should always look at it for anything. Because when you're looking at the rubric, you can say, oh, I'm missing this piece. I got to add this piece into it. No matter if it's paper, project, lab work, right? So what we know, right? So if you then have those steps about, and it doesn't have to be exact words. It just has to be, it can be your words, but saying the same thing, right? What's the power? Writing the parentheses twice or number times the exponent says. We got to double distribute, which means we're going to take each term of the first parentheses, distribute into the second parentheses. Huh? Third, we got to combine like terms. Right? That's it. And what the heck like terms are? That's 4 points. That's a lot of points. And why do I have you guys do that, though? It is. But why do I have you guys do that? It's not for Suzy Q, because Suzy Q doesn't exist. I understand. To show me that even if you're using AI, you know what the heck's going on in class. Number one. Number two, when you're creating your best cheat sheet ever, those things should be in it if you're struggling with that. So when you're taking the quiz and you're like, crap, I don't know how to do this. Let me go and grab my lab work. Oh, there's my steps right there, right? Not just grabbing chance steps, but it's got to be your thing. Work on understanding. The work is good. Question is, did you show double distributing, right? You got to show the double distribute. So 2x parentheses, -9 parentheses, right? You got to show that. That'll be 4 points. And then the quality of scan is only 2 points. So 80% of your work is up there. The other 20% is how well you wrote it, how well you scanned it. Did you do it in order? Do we still have issues with scanning multiple pages into one file? Right? If we still have those problems, I don't mind helping. Not at all. Again, you need to be a self-advocate. You need to advocate for yourself. Right? This is why I'd rather be someone being truthful about things so that we can find a path to correct it. Right? And the importance of a rubric. Right? Before, I didn't have a rubric. So I just graded off of what I see. And what I started to find is that sometimes I can't keep my feelings out of things. Right? And you don't really want someone grading off of feelings. Is that fair? All right? And I don't think it's fair either. That's the reason why I created a rubric, because I didn't feel like it was fair. I'm sure the students didn't feel like it was fair. Okay? And at the age of AI, I need to do something different so that you guys are showing that you're learning. Because here's the other question. Would you rather me have open-ended questions on the exam? I would tell you, trust me, you don't. Right? And the reason is because, now, if I put open-ended questions on the exam, then we don't have to have lab work. But I'm going to guess that you're going to freak out more. Way more. And I used to have so many problems that were multiple choice and so many problems that were open-ended. It was like 80% multiple choice, 20% open-ended. I would tell you that 95% of the students that took the exam skipped the open-ended questions and took the 80%. Because they were scared, and thank goodness it was 80% of their grade, so they're like, I'm good with it. I'm going to try to ace the multiple choice part. But the highest you can get is an 80%. Right? So that's where the issue comes into play. That's why I let you guys do it this way, so that you have your open notes. Is it more? Yes. But I don't look at it as how you would do MLMs. Because MLMs, to be honest with you, I have no idea if you're doing your own work. I have no clue if you're cheating out on every single problem. I have no clue. Zero ideas about that. Is that fair to say? right? You could cheat on every single problem on MLM. I'll have zero clue about that. There's no way of proving it, right? And I can't put feelings in there because it's self-grading, self-submitting. I got nothing to do with it. So if you guys cheated, I'll be like, and that's the reason why I don't like MLM. Your question. Absolutely, I thought. Yes. Absolutely. No problem. I got it right here. No problem. So any questions on that? Is it fair? Now, here's my next question before I answer his question. If I was to give the students that handed one in 100%, would you be willing to put more time into what we know? And again, I don't mind you using ChatGPT. But I want you guys to take the AI. So again, remember we talked about there's a fine line between cheating and not cheating, right? If you take AI, copy and paste, that's cheating. So if you copy, oh, shoot. Dang it, doesn't work. So if you were to copy this straight up, or from Mathway, or from Photomath, cheating. If you were to take this and saying, okay, let's look at his notes. And here's the scary part. I did a problem for you. I did a similar problem, right? So let's take that part. And since he didn't write everything down, right, meaning Chan, didn't write everything down of what we know, let me go back to the video of that part. What the heck did he say? And if you go back to the video, I promise you it's going to tell say what's the power attached to. Everybody's going to say parentheses. That means we do what? Write the parentheses twice, right? Then you go, okay, those are the things I got to write down. Is that fair? So I don't mind overlooking this. But I do want you guys to understand that it does upset me when I see this, because it means that you're not willing to self-advocate for yourself. I need you to. I need you to tell me when I'm wrong. I'm good with it. I don't mind having that discussion of why I'm wrong. Right? As upset as I get, I'm not going to yell at you guys about it, because at least sometimes I'm going to find out it's too much. But I want you to understand why I do it, so that it's not necessarily too much. I promise you that if you put time into this, it's going to help you on your exams as well. I promise you that. Okay? All right. So let's get to number 6. I better put this down because okay? This way nobody gets confused and going, hey, it's in the notes. I see it. It's there. It's recorded. All right, so number 6 says that f of x is equal to x squared minus 7x plus 9. So let me ask you this. If I was to ask you to find f of 2, how would you find that? Beautiful. Right? You do exactly that. Okay. So this problem doesn't ask for that. It asks for f of a plus h. What's the difference between that and 2? There's no difference. Because remember what I said to you guys. Every letter is just a number. Every parenthesis is just a number. So A plus H is just a number, just like 2. Okay? So if I was to find f of 2, and you said anywhere there's an x, I would replace it with 2. Same thing here. Anywhere there's an x, I'm just going to replace it with A plus H. Oh, shoot. So in this equation, here's an x. Here's an x. I'm just going to replace it with A plus H. So far, so good? Okay. That's understandable. Okay, great. Now, what is the power attached to? Parentheses, which means we got to write the parentheses. Beautiful. When binomial times binomial, what do we do? Huh? Double distribute. Take the first term, multiply by the second parentheses. Take the second term, multiply by the second parentheses. Now we have a squared plus AH plus AH plus H squared. Here we have to distribute. Minus 7a minus 7h plus 9. Does that make sense? We're okay there? Okay. So notice that putting in a plus h is 1. 2, we take each one individually, right? We don't have to try to solve the whole thing at once, right? Now we combine like terms. Those are my like terms, and that's what it adds up to. And that would be my answer, actually. There we go. Good? Okay. Any other questions? Yes?
For like this side of the bracket, do we have to write exactly that, or can you skip some steps?
You can skip some steps, but just, I guess it all depends on what steps you're skipping. Like, for example, okay, how about if I put it this way? So let me go back to here. So remember when I first wrote this to show double distribute? I showed that, right? And then I went one step further. You can skip that. But I think you got to show the double distribute, okay? And the reason why we show the double distribute is because when we get going backwards, you're going to see this, you're going to see this, you're going to see this to get to here. Notice that in here, you see the double distribute. So today we're going to talk exactly that, right? We're going to work backwards, and we're going to get to here from there. And you're going to see exactly this, and you're going to see this double distribute. So if you don't show the double distribute part, that's where we get in trouble, okay? And I'm going to say that more is always better than less. But I got to be careful with that because more could be wrong information, right? So let's say if someone says this here, about this piece right here, and says that a times b raised to the n equals a to the n times b to the n. That's wrong information. Okay? That's wrong information. Because you're like, well, a chance that more would be good, better, right? If it's wrong, then it can't be, right? But I guess I wouldn't mind this. I'm okay with that, right? Because there's really no other exponent rules that should go into this, I guess. Because the other rule that I just put down is where people made mistakes when we did it the problem the first time. They try to square the first term and square the second term and say that's what the answer is, right? So that's why, and that was based on multiplication and division, has nothing to do with addition and subtraction. Any other questions? Yes? Sure. Ooh. It'd be nice if I wrote down the right problem. What is the power attached to? To the parentheses, which means that I have to distribute the power to every single one. And that is the first step that I gave, right? So what do I have? 2 to the x to the y to the z to the do they all like where they are? Yes. 2 likes me on top, x likes me on top, y likes me on top, z likes me on the bottom. They all have positive attitude. So the only thing we got to do is simplify that. Make sense? Okay. So the 3 steps is distribute, move, simplify. Any other questions? That's fine. I would prefer that you did on both. And I think that's the reason why that's why I would like, how would I put it? Let's go back. So this is what I tend to do, and this is something that you guys might want to do. So let's say here, right, I say combine like terms. Let's say I put down step 3, right? Then I might put this over here, right? So it shows that when I combine like terms, it's that. So instead of writing combine like terms, you can just do it that way as well. So it kind of refers it back to it. Makes sense. Makes sense. Any other questions? We're okay? No other questions? All right. So let's talk about factoring. Still step 2. We use the AC method when there's 3 terms. So with 4 terms, what method do we use? If it's 4 terms? Huh? Factor by grouping, FBG, right? Now it's 3 terms. We're going to use the AC method. So So I'm going to throw a warning out to you right now. I'm going to throw a warning out there to you right now. Ready for the warning? Here's the warning. You're going to be factoring problems in front of your friends, family, tutor, and they're going to say to you, "Oh, there's an easier way. Just do this." Okay? I'm going to tell you to bring that easier way back to this first example. Okay? If it doesn't work here, don't use it. Because here's the problem. Well, how about this? I make you a promise. I will personally make you a promise. I will personally show you what the easy way is. And when you can use it after you have the AC method down pat. You have it down, I'll teach the whole class what the easy method is and when you can use it. And I'm going to tell you right now, the easy method cannot be used here. Okay? I'm going to tell you that right now. So if anybody else gives you a different method, I want you to apply it to this problem and see if it works. If it works, bring it to class, we'll talk about it, and then we'll go from there. Fair? Okay. All right, so let's talk about the AC method. Step 1. Do you guys agree with this, that you guys all learned the quadratic formula before, back in the day? Do you agree that this follows a standard form called ax squared plus bx plus c? So the a is a 3, the b is a -10, and the c is a 7. Everybody see that? Okay. So step 1 is this. It's a times c, which is in this case equal to 3 times 7, which equals a positive 21. Everybody agree with that? Do we know where the 3 came from, where the 7 came from? So we know where the B came from, where the 7 came from? I mean, sorry, where the 3 and the 7 came from? That's the A and the C, right? Okay. The B is equal to negative 10. We're still in step 1. So again, A is a 3, C is a 7, and B is a negative 10. Okay so far? All right. So the whole purpose of the AC method is that we're trying to find two numbers multiplied together that would give me 21, and the same two numbers added together will give me a negative 10. So what two numbers multiplied together would give me a positive 21, but added together would give me a negative 10? Negative 3 and negative 7, or negative 7 and negative 3. Awesome. Now again, these got to be the same numbers. They don't go different numbers. It's the same numbers. Okay? Now, there is a Cuban way of this, and maybe this is, someone said the X method. Maybe this is what they meant. So Cubans, and yes, I learned this from a student. Yes, a student from Cuba. So what they do is this. They put the A times C on top. They put the B on the bottom. And they're trying to find those two numbers, so they'll get the negative 7 and the negative 3. So instead of writing all of this out, if you want to do this, that's certainly fine. Okay, this is the Cuban method, or that's the way they teach it in Cuba. Any questions there? I don't care either way, it's fine. Because I kept on seeing this on the Cuban students' paper. I'm like, what are you doing? Explain this to me. So they explain it to me. They're like, we're doing the same thing. The cool part about the X is that people don't get confused that these are supposed to be the same pair of numbers, right? Because it's like these two multiplied together gives you that, add together gives you this. Okay. All right. Everybody kosher with step 1 so far? Any questions on step 1 so far? We're good. Step 2. Do we know what the result is? Yes. Yes. And if you need a way to remember that with A, it's A times C, right? So we know that we're looking for two numbers to multiply together. So multiplying goes together. And the other is adding. So with the results in step 1, so do we know what the results are in step 1 that we're looking at? The -7, -3. Okay? It's a -7, -3 that we're talking about. Okay? So I'm going to come over here. I'm going to use those two numbers. To split the 10 apart. So I'm keeping the 3x squared minus 7x minus 3x plus 7. Does everybody see that? Now, do we understand why I put x in here? Because these two have to add up to this. Right? This is negative 10x, so I need a negative 7x and a negative 3x. Questions? How many terms do I have now? 4? How do I factor 4 terms again? Broken? Grouping, yes. Now, does it matter if I wrote negative 3x first or negative 7x second? It doesn't. Because negative 7x minus a 3x gives me a negative 10x. Negative 3x minus a 7x still gives me a negative 10x. So which one you put first doesn't matter. Okay? So, factor by grouping. Split into 2 groups. Factor the first group by itself. What's my GCF in the first group? What do I have left? For the ones that don't see it, ooh. Do we see it now? What's my GCF in the second group? Thank you. What do I have left? Because I want these two parentheses to be the same. Use this parentheses as a guide. Do not force this. You force this, it's going to be wrong. So use this as a guide. Once you get this, you go, okay, let me put this over here. What do I need to pull out so that I will have this? All right. So factor as a whole, what do I have in common? And what do I have left? Now do you see what I'm saying when we go backwards? Because last week we were given this. We talk about double distributing, so it shows like this. Right? And then we would distribute and we get this line here. And then we combine like terms and we get the question. So does everybody see that? Right? So this is exactly backwards from what we learned last week. Exactly. Any questions? Yes? No. That's why I was saying, once you get this, use it as a guide here and say, so that this stays the same. You want that to be the same. Okay? Any other questions? These terms? So remember when we broke them down in primes before? So when you look at this basket and this basket, what do you have in common? Just the x. I highlighted the x here. So that is this piece here. Is why I circled. So you see the 3x and then the 7. Cool? Mm-hmm. And remember with this one here, remember the rule that I wrote down. If the third term is a negative, pull a negative out of the second parentheses. Remember that rule? So maybe in your what we know, you might want to throw that piece in there. Because that should be in your notes, yes? Okay. But you didn't factor last week. Was there factoring? Okay. Ready to try one on your own? All right. Let's see how we do. Good luck. You guys don't need luck. You guys got this. A times C. Yikes. Oh, we need our calculator for that? Fair. No, it's fair. It's fair. It's fair. It's big. Two big numbers. Well, a big number there. Laying, say 120. I'm sorry, 1280. Is that right? Where's your B? Dang it. All right, I want to pause you guys here. I want to pause you guys right here. So I'm actually going to show you two different ways. Well, it's not two different ways of doing it. Because we're in the middle of the AC method, your first thought is AC method. Great. So okay. So here's what you guys start doing, right? You guys are like, nope, 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 nope. Here's the problem, though. What's going to happen with you guys is that you guys are going to keep on running into the same numbers over and over. So you're like, divide by 5. Nope. Divide by 2. Nope. Divide by 10. Nope. Divide by 5. Nope. Divide by 14. Nope. Divide by 60. Nope. Divide by 5. Nope. Right? You're going to keep on hitting the same number over and over. So remember last week I was telling you that that factoring table will come handy at some point. Here is where those points are. When it's a 1280, right? So here's what I'm going to tell you to do. Take the 1280, and let's find the factors of 1280. So there's a positive 1280, isn't it? So if I multiply two numbers together to give you 1280, those two numbers have to be what or what? To give me a positive 1280, they both have to be negative or positive, right? Because negative times negative gives me positive, positive times positive gives me positive. However, the sum of those two numbers has to be a negative 72, which means those two numbers are negative. Does that make sense? They have to be. So I'm going to put a key right here. Negative 1, negative 1280. Because if I add those two together, isn't that going to be negative? Right? And if I multiply those two together, it's going to be positive. Exactly what I wanted. Okay? I know there's a guide. There's only a guide. I know that this is not going to be the result. So let's try negative 2. Is that right? You're like, Chan, if we go to 3 and 4 and 5, it's going to take forever. You're right. Let's do this. Let's double the negative 2. Let's take a jump to negative 4. Let's jump to negative 8. Let's jump to negative 16. Let's jump to negative 32. Did we find it yet? What is negative 32 plus a negative 40? It gives me the negative 72, doesn't it? So this right here will equal... Oh. So I just found my two numbers. Does that make sense? Right? So isn't this much easier than just stabbing at your calculator? Over and over and over and over again? Right? Now, will this always land on something that we can use? No, not always. Okay? So here's the thing. Let's say we were looking for, I don't know, negative 80. Let's say we were looking for negative 80, right? If you look at this one right here, this gives me a negative 96. Is that right? If we add these together, negative 96, this gives me a negative 72. So that means negative 80 got to be in here somewhere. Does that make sense? So now I know it's between negative 16 and negative 32. It's probably closer to negative 72 because it's negative 80 than negative 96, which seems further away than negative 80. So I'm going to try 31, 30, 29, and so on. Does that make sense? Okay. So this doubling just helps me making bigger jumps. Okay. All right. So I found my numbers. All right. You guys can finish from here. So. In case if you guys need it broken down so that you guys can see the GCF. Some of you guys might not see it. That's why sometimes we do need to break numbers down because now we're not very good at GCFs, right? Why do you have those two? Aren't you supposed to break this down with these two numbers? Just like I did here. So why did you change it to 160? Oh, keep on going. You're fine. I see what you did. That's what 160 is. That's what 160 is. When you did prime factorization. Remember the factor tree? Ladies and gentlemen, this is what I'm seeing when I'm walking around. I see that you guys need more work on factor trees. Because I'm seeing that you guys can't find the GCF of 8 and 80 and 38 and 32. You're just guessing. Look at what I broke it down to. So the numbers up top, guys, above, is if I did a factor tree of 8, it'd be 2 times 2 times 2. Y squared, y times y. Factor tree for 32 is 2 times 2 times 2 times 2 times 2, 5 of them, times y. So if you look at those two, I have 3 2's that are in common and a y that's in common. That would be an 8y. That's the GCF. And what I have left, if you look, will be a y minus 4. Because 2 times 2, if you look at the circled. Does that make sense? Huh? Yep. Now, I'll also explain this. If you guys decide to use 2, 4, or just y, you're not wrong, you're just not right. I'll explain how to go about doing the other. That's the reason why I showed you guys factor trees. And I told you guys, the more factor trees you do, the easier it is. Same thing as what I did here. I'm not any smarter than you guys. I promise you, I'm not any smarter than any one of you. The difference between you and I, you know what it is? Is that I've done 10, 100,000 more problems than you have. That's it. If I gave you 10,000 numbers and you did factor trees of 10,000 numbers, you can teach the same thing. You would write down 2 times 2 times 2 equals 8. 2 times 2 times 2 times 2 times 2 equals 32. 2 times 2 times 2 times 2 times 2 times 5 equals 160. You guys can do the same thing. If you're wondering how I did 160 so quickly, this is 16 times 10, isn't it? Okay, so 16 is 2 times 2 times 2 times 2. There's 4 2's. 10 is 2 times 5. I got another 2 here, and 5. Done. 40 is 8 times 5. Well, 8 we already know. 2 times 2 times 2 times 5. Done. I'm not any smarter than you guys. I've only done more problems. That's it. If you guys do as many problems, you guys can teach the class just as well. So if you look at my highlights, you will see that I have 8y, leaving me with y minus 4. And since the third term is a negative, I got to pull a negative out. Look at my highlights. That's a 2 times 2 times 2, which is 8, times 5 is a 40. I have y minus 4 left. Now, remember what I said to you. If you decide to only pull y out, you're not, or 4 out, or 2 out, you're not wrong, you're just not right, correct? I did say that. So let me show you guys what I mean by that. So let me take this right here. Let me move it down so that you guys don't see anything else, okay? So let's say, for example, so you said to me that you pulled out 4y. So you'll get a 2y minus 8. Is that right? Okay. So what I want to do then, if I'm not sure if I got everything, I want to look in this parentheses again. Okay? So let me shift this over. If I just look at this, is there a GCF? Two does, because this is even, so 2 does, right? So that means I can, so the 4y is already pulled out. Then if I pull out 2, then I'll have y minus 4. See the two numbers outside? Doesn't that give me an 8y? So you're not wrong, you're just not right yet. Is that fair? If you want to keep on doing that, you're welcome to, but you're just going to make the problem longer. Make sense? Okay? So, and this is the reason why I tell you guys you should watch the video, is because I do that. Now it's not in the notes anymore, right? Or you guys can do the factors. Again, clearly, I can see one person really good at GCFs in here. But majority of you guys aren't awesome at GCFs. And I don't blame you. That's the reason why you're in this class. Right? That's the reason why you're in this class, is try to figure out what's the best way of finding GCFs. I'm telling you, that's what it is. That's literally the easiest way. Now, you're probably saying to yourself, that process is way too long, dude. Why do I want to even do that? I can't disagree with you. But I'll tell you this. When we get to square roots, radicals, you're going to wish that you did enough factor trees, because there is all just factor trees. Literally all just factor trees. So you want to get good at radicals, you better get into the factor trees now. So that when we get there, it's going to be cake. Or you remember all the perfect squares, You remember all the perfect cubes, perfect fourths, and perfect fifths. You want to remember those tables? Go for it. I do not want to remember them. But as an engineer, I had to remember them. I had to know them as an engineer. How many of you guys going to engineering? Oh, dang it. Son of a gun. So I can't expect that from you guys, to remember perfect squares? But again, I'm telling you right now, I use factor trees to teach that as well, because I find factor trees the easiest way to teach that. Same thing, it's the easiest way to find GCFs. So the more you do now, the easier it is going to be later. I promise you that. Just like I'm going to tell you right now, you're going to try to find the easy way of AC method. I'm going to tell you right now, if you don't hammer down on AC method, you can cheat yourself. I shouldn't say cheat. You can find a path to pass exam 2, no problem. But if you don't get the AC method down, exam 3 is going to, you're going to bomb exam 3. Not fail exam 3, bomb exam 3. There's no way of getting around not knowing the AC method in exam 3. There's a way around for exam 2, but not exam 3. Okay? So either you put in the work now, or you're going to put in the work later. And I'm going to tell you right now, the students that I have in college algebra that took me, got the AC method down, they're doing much better than the students that didn't have me and don't have the AC method down. The AC method is going to haunt you. All right? Yes? Oh. Well, you don't. Well, kind of. Because here's the problem. This is not the final answer. Remember how I said to you guys, I'm going to show you guys 2 ways, but because we're in the AC method, that you really haven't gotten the right answer yet? Because what do you notice about one of the parentheses? What do you notice about the red parentheses? There's another GCF in there, isn't there? Do you guys see the GCF in here? Some of you guys are like, no. I don't see a GCF in there whatsoever, dude. Well, there is. Here it is. That, ladies and gentlemen, is actually your final answer. So if you did that to your problem, you're going to get the same answer. So I'm guessing you had 8y minus 32. So you pull the 8 out, you have y minus 4. They have the y minus 5. True? So you'll get exactly the same answer. So why is this? I'll explain to you guys why. What's the title of this? Factoring. Step what? What the heck was step 1? No. But this title right here says factoring, step 2. What the heck was step 1 in factoring? Let's find out. Oh, wait a minute. step 2 too. What the? You mean we got multiple step 2s? Yes. But this step 2 was what? About how many terms? 4 terms. This step 2 was about how many terms? 3. So what the heck was step 1? Ooh. Factoring, the first step. GCF. What? You mean the very first step we're supposed to do is GCFs? Ah. All right. Shrink. Go. Go. Oh, don't go too far. All right. So let's bring this back again. Too high. That A looks familiar, doesn't it? So we look at what's left. And what's left, how many terms are there? What method should we use as our second step? AC method. Does that make sense? So the 8, guys, for right now, we're going to ignore the 8. I'm just going to put an arrow here to remind me, hey, the 8 belongs as part of the answer. Okay? I'm just going to do that. But I'm going to look at what's left. Now I'm going to do the AC method. Oopsies. That's supposed to be bleu. Eight. Two numbers multiplied together to give you 20, added together to give you negative 9 is negative 5, negative 4. GCF of the first group is, leave me with, GCF of the second group is, leave me with, oops, GCF of the whole group is, what's left? Oh, look at that arrow. Oh, look at that answer. So you guys see how using the GCF made the AC method much easier? But because we forgot about the first step. Right? Now here's the thing. I don't blame you. It all depends on how your brain works, right? If you think of GCF first, great. If you don't, it doesn't mean you're wrong, right? Because that's the way we did this problem right here. We did not think of GCF first. But we can fix ourselves. Make sense? Just like we were saying, if you happen to pull a 4y out of here, you're not wrong, you're just not right yet. Same thing here. We got this answer. We're not wrong, we're just not right yet. That's it. But here's the thing. Why did I show you guys this? I show you guys the factoring table because there's going to be times that we're not going to have a GCF and we're going to end with a really big number. That's why I show you guys this. That's the reason. Does that make sense? Questions? No questions. We're good. Are we sure? No questions whatsoever. All right. Then let's get to factoring. Step 2. Is there ever going to be a step 3? No. There's only step 2. We got step 1, and then step 2, step 2, step 2. We talked about 4 terms, we talked about 3 terms, now we're talking about 2 terms. So anytime we have 2 terms, the question to ask is this. Is it the difference of 2 perfect squares? What's the word difference mean in math? Subtraction. So if we see 2 terms, if it is not subtraction, we can't factor. Got it? That's why it says difference. What does it mean by perfect squares? Do we know what perfect squares are? Give me some perfect squares. 4, 16. We skipped a bunch, huh? How do we find perfect squares? Is that right? $25, 36, 49, 64, 81, 100, 121, 144, 169, 196, just flip those 2 numbers, 225, 256. I think I'm done there. Dang it, sorry guys. Failure. So those are perfect squares. How do we find them on the calculator? How do I know if 256 is a perfect square? Mm-hmm. Are you going to go 1 times 1, 2 times 2, 3 times 3, 4 times 4? Take the square root of it. Take the square root of it, and if it comes out evenly, it's a perfect square. Make sense? That's 16 times 16, right? Okay. So how do I figure out if variables are perfect squares? So to find numbers, I just did 1 times 1, 2 times 2, 3 times 3, right? Okay. Let's do it with variables. X times x gives me what? X squared times x squared. Let's see if you guys get this one right. Punch you guys in the face. What do we do with the powers? Add them. Right? What do you notice about these powers? They're even, aren't they? So if the powers are even, then they must be perfect squares. Make sense? And notice going backwards, right? Because we know 16 is a perfect square because if we took the square of 16, it'd be 4. I know x to the 6 is a perfect square because if I take the square of x to the 6, it's going to be x to the third. Does that make sense? So, is it the difference? It is a difference, subtraction. Of two perfect squares, is c squared a perfect square? Is 64 a perfect square? Yes. So here's how I'm going to show it to you guys. Ready? So, subtraction check. What times what gives you c squared? C times c. What times what gives you 64? Ready for this? Plus, minus, and you're done. How would I do this one? Is it the difference of two perfect squares? No, because it's not subtraction. Even though these are perfect squares, it's still not subtraction. I gotta use a little boy. So this factorable? This is why I gave this problem to you guys. Is there a GCF? Okay. So, since there is a GCF, you pull the GCF out. You got that. Is that right? Everybody see that? Because I was able to do step 1. That is my answer. Do you guys see the difference between those two examples? This example here, I had no GCF. I couldn't do anything. I couldn't begin step 1, so therefore it's not factorable or a prime polynomial. This one, I was able to get step 1 done, so factoring was already done. That's why there's an answer. Fair? Okay. How about this one? How do I go about doing that problem? Any ideas? Huh? Is it? 25 is. 100 is. But 125 is not. So the first thing you guys are going to do is you're going to solve square root of 125, square root of 180. It doesn't come out evenly, right? So you want to go not factorable. But problem. Is there a GCF? What is it? Sabat isam. Is that right? I think that's right. Someone check me. See if 2 times 2 times 3 times 3 times 5 equals 180. Yes?
Yeah.
Oopsies. I forgot the other x, huh? I don't know if you guys noticed this or not. Do you guys notice something here? Oh, it's not 6, you dodo. Look at the pairs that's already there. What's 25? 5 times 5. What's, x squared? X times x. 36? 6 times 6. Questions? All right. Oil. Yes, that's a perfect square. Find out what it is. $64. 64. Is it just that? What times what gives you x to the fourth? What times what gives you 4096? Oh, that's 64. So draw your parentheses. There's only two of them. Never. Is that the answer? Double distribute. Have you guys ever wondered why I do this? Is that the answer? Why? Oh, look at this. Is that the difference of two perfect squares? Subtraction, isn't it? X squared is a perfect square. Is 64 a perfect square? Yeah. Can I break this one down anymore? I can. Is it the difference? Not that one, but this one is. Do you guys see this? So anytime I have an x that's to a higher power than 1, I want to double check to see if there's a perfect square. But this is the reason why I draw those arrows, is because then I'm not stuck with just one, but I have both factors. That's why I use the arrows. Because it's got to be both. It's not just a 1. So it shouldn't matter. Bottom line is you need to have all three factors. Because this is just a number, this is just a number, this is just a number. So it doesn't matter if this is in front of these two. No, it doesn't. Questions? Yes, sir. Because, remember the question we asked. Is it the difference? So in between these two, it has to be subtraction. If it's not subtraction, I can't factor it. So in this one, I can't factor that one any further. But this one here, is the difference, so subtraction, then I ask myself, is these two perfect squares? Since they are, then I can break it down further. Make sense? Okay. So if it's not subtraction, I'm done. Right? If it's addition, I'm done. Okay. The only thing that can go further is GCF, and that's about it. Okay. Any other questions? Great question. Thank you. Sorry for belittling you and yelling at you. Sorry. Any other questions? Well, it's our time, ladies and gentlemen. So please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Wednesday. Later.